In this video, we'll be finding the extrema of a function on a closed interval. Our first step will be to find the derivative of the function and then set it equal to 0. When we solve, those x values will be the critical numbers of the function. We can also get critical numbers if the derivative is undefined. Our next step is to evaluate the function at each critical number, and then evaluate the function at the endpoints of the interval. And then the minimum will be the least value, and the maximum will be the greatest value. Let's do an example. We're asked to find the extrema of f of x equals 2 sine x minus cosine 2x on the closed interval from 0 to 2 pi. So our first step will be to find the derivative. The derivative of 2 sine x is 2 cosine x. The derivative of cosine is a negative sign. And then we need to multiply that by the derivative of this inside function, which will just be 2. So let's simplify this. We'll put this 2 out in front and take a look at it. It's going to have to equal 0. So I have 0 equals 2 cosine x plus 2 sine 2x. Now what I'd like to get is this sine 2x. I'd like for it to be in terms of just x as the argument. So I can use trig identity. Sine 2x is equal to 2 times the sine x times the cosine of x. So let's put that in there and see what we get. 2 cosine x plus 2, and then instead of sine 2x, I'm going to put in 2 sine x cosine x, and then that's equal to 0. So let's see, 2 cosine x plus 4 sine x cosine x equals 0. I can factor out a 2 cosine x, and I'll be left with 1 plus 2 sine x equals 0. Now I need to set each of these factors equal to 0. Cosine x equals 0 when x equals pi over 2 and 3 pi over 2. Set this equal to 0. 1 plus 2 sine x equals 0. Subtract 1 from both sides. 2 sine x equals a negative 1. Divide by 2. Sine x is equal to a negative 1/2. Let me draw a picture of this one. My sign is negative in quadrant 3 and quadrant 4. And I have a negative 1 over 2. So this reference angle will be pi over 6, which means 6 pi over 6 plus pi over 6. So x will be 7 pi over 6. And then over in this one, again, the reference angle is pi over 6. So 11 pi over 6. So these are my critical numbers. Let me just list those. Pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. Right, now what I want to do is evaluate my function at each of those. Let's see, my function is up here. So I need f of pi over 2, f of 3 pi over 2, f of 7 pi over 6, and f of 11 pi over 6. So my mode has to be in radians, alright. And I have 2 sine x minus cosine 2x. Oh, and I also need to evaluate at my endpoints. So let me list those as well. F of 0 and f of 2 pi. Pi over 2, sorting for x, gives me 3 pi over 2, store x is negative 1, 7 pi over 6, store x is a negative 1.5, 11 So, looks like we have a max right here at pi over 2, 3. And I have 2 mins. One is at 7 pi over 6, negative 1.5. And the other is at 11 pi over 6, negative 1.5. This would be an interesting function to look at. I think I'd like to see what that looks like. 2 sine x minus cosine 2x. And we need a zoom trig, so number 7 there. That's interesting. We can set our window. This was just the generic window. But we can set our window so that the min is 0 and the max is pi. Our y min y max. So we have a max up here, that's that pi over 2, 3. We could probably say that we have a relative max at this point. This is that at 3 pi over 2, that would be a relative max.